Hi everyone. Today we're going to talk about solubility product constant. This is tied to the learning objective 6.21 and 2.2 from the College Board, saying that students can predict the solubility and interpret data regarding KSP. Remember the solubility rules? We are expected to remember that all sodium, potassium, ammonium, and nitrate salts are soluble. However, we do not need to memorize the following solubility rules because they will be provided as a hint in the problem. That the salts of chloride, bromide, and iodide are soluble except when paired with silver ion, lead 2+ ion, and mercury 2+ ion. That salts or sulfates are soluble except when paired with group 2 calcium, strontium, barium ions, and also silver, lead, and mercury ions. That the salts of sulfide, carbonate, phosphate, and hydroxides are mostly insoluble, especially when paired with transition metals. When an ionic solid of low solubility dissolves in water, ions are formed, as in the picture. Now, as the ion concentration increases, they will collide and reform the solid. So a dynamic equilibrium is reached when the rate of dissolving is equal to the rate of precipitation. That means a saturated solution is formed. It is a solution in equilibrium with undissolved solute. Any addition or evaporation of water to the saturated solution or any additional solid will not change the ion concentration in a saturated solution. When we write equilibrium constant for these kind of dissolving of sparingly soluble solid, we call it the KSP, solubility product constant. Now, when we dissolve silver carbonate in water at equilibrium, the equation can be written as silver carbonate solid, double-headed arrow to form 2 moles of silver ion and carbonate ion in aqueous solution. So when we write the KSP is equal to the silver ion concentration raised to the power 2 because of the coefficient of 2 in the stoichiometry times the carbonate ion concentration. And remember, we represent concentration by the bracket. The solids are omitted from the expression because their density is constant. That KSP is dependent on temperature. When temperature increases, KSP value will also change and increase. Solubility of ionic solid in water increases with increasing temperature. Now here's a term we need to understand, molar solubility. It means how many moles of the ionic compound are dissolved in 1 liter of the saturated solution. So for example, if we have silver chloride dissolved in water, we write the equation as formation of silver ion and chloride ion, and KSP is given at 1.6 times 10 to the minus 10. Now these values are listed in your textbook that you can look up from a table. From the stoichiometry of the equation, we understand that as 1 mole of silver chloride solid dissolves, 1 mole of silver ion and 1 mole of chloride ions are formed at equilibrium. So the best way to do this is to set up a nice table and let X be the molar solubility of silver chloride. That means initially we have no concentration of silver and chloride ions, but the change of each will be X because it's a 1-to-1 mole ratio. So at equilibrium, we have the concentration of silver and chloride ions both being X mole per liter. Now we write the KSP expression equal to silver ion times chloride ion. And let the KSP be equal to X squared, and solving for X, which is 1.3 times 10 to the minus 5 mole per liter. That X represents the concentration of silver and chloride ion as well as the molar solubility of silver chloride. Now, numerically, they are the same, but they do mean different things. Try practice problem number 1. Given the KSP of lead chloride, 1.6 times 10 to the minus 5, find the molar solubility in mole per liter and grams per liter? And what are the concentration of lead ion and chloride ion at equilibrium? So first we write the equation, dissolving of lead chloride to form lead ion and 2 moles of chloride ion. Now let X be the molar solubility of lead chloride. That means at equilibrium, we form X mole per liter of the lead ion and also 2 times X for the chloride because of the stoichiometry. Now we write the KSP expression equal to lead ion times chloride ion raised to the power 2. Please do not forget about the power 2. So let the KSP value be equal to X times 2X raised to the power 2, which is 4X cubed. Solving for that, X is 1.6 times 10 to the minus 2 mole per liter. Now that is equal to the molar solubility of lead chloride. And if we take that number and convert it into grams by multiplied by the molar mass of lead chloride, 278.1 gram, we have 40.5 gram per liter. The lead ion concentration is 1.6 times 10 to the minus 2 mole per liter, while that of the chloride is 2 times that number, which is 3.2 times 10 to the minus 2 mole per liter. Try practice problem number 2. Solid calcium fluoride dissolves in water to form a saturated solution at equilibrium given that the fluoride ion concentration is 4.4 times 10 to the minus 4 molar. Find its KSP. Now first we write the equation. 1 mole of calcium fluoride dissolved to form 1 mole of calcium ion and 2 moles of fluoride ions. Now let's calculate the calcium ion concentration from the fluoride ion concentration using a mole ratio of 1 to 2. Now the calcium ion concentration is calculated as 2.2 times 10 to the minus 4 molar. And then we write the KSP expression equal to calcium ion times fluoride ion raised to the power 2. Then we substitute the numbers into the equation, and the KSP is calculated as 4.3 times 10 to the minus 11. Now that's a very small number, meaning that at equilibrium, very small amount of calcium fluoride will dissolve to make a saturated solution. To summarize what we have learned today, we learned that there is a dynamic equilibrium between solute and ion in a saturated solution of sparingly soluble ionic compounds. We also learned how to write KSP expressions. We understand the difference between molar solubility and concentration of ions at equilibrium. And finally, we practice solving KSP problems. I hope that you have found this video helpful to you. If you like it, please give us a like, and I look forward to seeing you in part 2.